Hello there, Mr. Sutton here, bringing you this Algebra 2 Honors 12-4 homework Part 1 solutions on inverses of matrices. For the first few problems, we're going to be finding the inverse of a matrix if it exists. It might not. So for all of these, I'm going to start by writing out the formula, and then we're going to plug stuff in. So here's our formula, 1 over AD minus CB, so basically the determinant, and then we switch the A and the D and negate the B and the C. So we're going to have 1 over 28 minus 27. And then for our matrix, switching A and D, we're going to have a 7 and a 4. And then we're going to negate the 3 and the 9. So 28 minus 21 is just 1. So this is just going to be this matrix over here because we're just multiplying all of that by 1. Let's find the inverse of this matrix. So here again is my formula. We're going to have 1 over, 17 times 3. That's going to be 51. And then subtracting 4 times 13, which is 52. So 51 minus 52. And then we switch the A and the D. So we'll have a 3 up here and a 17 down there. And then negating B and C, that's a negative 13 and a negative 4. 51 minus 52 is negative 1. So we're just going to have a negative 1 being distributed to this whole matrix here. So that gives us negative 3, positive 13, positive 4, and negative 17. To find the inverse of this matrix, let's use our formula here. So we've got 1 over the determinant. So 1 over 12 minus 9 if we do each of those multiplications. And then switching A and D, we have a negative 6 up here, negative 2 is moving down to the lower right. And then these 3's are both going to be negated because of negative B and negative C. So this is 1 over 3 out there. So we're just going to distribute 1/3 to each of these items in the matrix. So negative 6 is going to become negative 2. Negative 3 is now negative 1. Negative 3 is still negative 1. And negative 2, that's going to become negative 2/3. To find this inverse, let's go ahead and try out the formula. So we have 1 over the determinant, first of all. We've got negative 12 minus another negative 12, so that's negative 12 plus 12. That's actually 0 down there before we bother with this matrix. Since we have a determinant of 0, that tells us that there is no inverse. Next up, we're going to try to solve this matrix equation. So basic idea is we need to find the inverse of this A matrix that's being multiplied by the x, and then just multiply both sides by that inverse. So the inverse of this first matrix, that's going to be, just using our formula, we have 1 over the determinant. So 1 over, this will be 6 minus 35. That's going to be interesting. And then we have to switch the A and the D. So we'll have a 3 up here and a 2 down there. And then negate the 5 and the 7. So negative 5, negative 7. So this is going to be 1 over negative 29. That'll be very interesting. Let me multiply that through, and then while I'm doing that, I'll multiply that times both sides of the equation. So negative 1 over 29 times 3, that's going to be negative 3 over 29. So this is my inverse matrix I'm setting up over here. And then negative 5 becomes positive 5 over 29. Negative 7 is now going to be positive 7 over 29. And 2 is now negative 2 over 29. And then I'm going to multiply this same crazy looking matrix by the 12, 9, 13, 17 matrix over on the other side as well. And notice that I'm putting this first to the left. If I put it the other way, it's going to give me a different incorrect result. All right, so we're going to do a little matrix multiplication with these two matrices, and I am not going to try to do this in my head. So let me pull up my Desmos calculator. Not the matrix calculator, just the regular one. So let's see, I'm going to do each row times each column. So we've got negative 3 over 29 times 12. And then we have to do plus 5 over 29 times 13. And if you can believe it, that comes out to just 1. Hey, we'll take it. So we got 1 there. All right, let me do this row times the second column now. I'm just going to replace the 12 and the 13 with a 9 and a 17. So this is actually not so bad if you're able to go back and edit your entries from before. Thank you, Desmos. So that gives us a 2 over there. And now I'm going to go back and do the second row times both of those columns. So now I've got, let me just start over, 7 over 29 times, now I have to do this times the first column, so doing times 12. And then we'll do, let's see, this will be minus 2 over 29 times 13. And that comes out to 2. Second row, first column, so we're down here with a 2. And then finally we're going to do second row and second column. So 12 and 13, again, we're going to replace that with 9 and 17, and that comes out to 1. So there is our X matrix. To solve this matrix equation, let's begin by finding the inverse of this matrix to the left of X here. We're going to multiply both sides by that matrix, and that's going to cancel this matrix out and leave us with X equals, well, whatever the inverse times this second matrix is. So first things first, inverse of this one. So that's 1 over the determinant of this matrix. So 1 over 12 minus negative 10, so 12 plus 10. And then let's switch the A and the D, so 4 and 3. And then let's negate the B and the C, so we'll have positive 2 and negative 5. So this is 1 over 22, and we're going to multiply that by each item here. And I'll just throw that down to the left of this matrix while I'm doing it to save a little bit of space. So we're going to have 1 over 22 times 4. That gives us 4 over 22, which we can reduce then to 2 over 11. So 2 over 11 is my first item in my inverse matrix. Next, 1 over 22 times 2, that's going to be 2 over 22, which is 1 over 11. And 1 over 22 times negative 5, so negative 5 over 22. And then this 3 is going to be a 3 over 22. So this is our inverse matrix. When we multiply it by this matrix over here, since it's the inverse of this matrix on the left, that actually cancels this out and leaves us with just X. But we also have to multiply this inverse matrix by the other side of the equation, and I'll have to put it on the left side of all that to do the correct order of multiplication. So let's multiply this out, and I'm going to get Desmos' scientific calculator to help me out with this. So let me do first row times first column. So we have 2 over 11 times 14 plus 1 over 11 times 16, and that comes out to exactly 4. So we've got 4. And then let me do that row times the second column. So 14 and 16 I'm just going to replace with 3 and 5. And then the total result from that is going to be 1. Next, let me do the second row times each column. So I've got negative 5 over 22 times 14, right? 14. And then we have 3 plus 3 over 22 times 16. And that all comes out to negative 1. It's amazing how these come out to such nice numbers, even though we're not starting with very nice numbers. And then finally, we'll multiply this row by the 3 and the 5. So let's just go back and change that to 3 and 5. And that comes out to exactly 0, which I guess kind of makes sense. You have negative 15 over 22 and positive 15 over 22. So 0. So this is our answer matrix. To solve this matrix equation, which unlike the other ones has a 2 by 3 over on the other side, so that's kind of interesting, we're going to get the inverse of this 2 by 2 matrix on the left. So let's crank this out here. We have 1 over the determinant. So that's going to be 1 over 2 minus 0, which is just going to be 1/2. Then for the matrix itself, we switch the negative 1 and the negative 2, the A and the D. And then we'll negate the 5 and the 0. That leaves us with negative 5 and still 0. So this is going to be 1/2 times all of these. So I'm going to have 1/2 times -1, or -2 rather, which comes out to -1. And I'm going to put this on the left here just to start that process. We've got half of -5, so -5/2. Half of 0 is still 0. And half of -1 is -1/2. And now I have to do this same inverse times this 2 by 3 on the right side. And we'll start multiplying this out. Let me see, can I do this without a calculator? Maybe, if I think of this as like a -2.5. So let's do the first row times each of these columns. So we've got -1 times 3 is -3. -2.5 times 6 is going to be -15. So 3 plus 15 is, or -3 actually, plus -15 is -18. Let's keep going. -1 and -1 is 1. And -2.5 and 8 is going to be, let's see, -20. So we had 1 and -20, so -19. For the last row, we've got -1 times 0 is 0, so it won't worry about it. -2.5 times 4 is going to be -10. Let's go through now and do the second row times each column. This will be even easier because we've got this 0 here. So 0 times 3 goes away. -1/2 and 6 gives us -3. 0 and 1 is gone. -1/2 and 8 is -4. And 0 and 0 is just gone. -1/2 of 4 is going to be -2. So there's our answer.